Lesson 13. In this lesson, we are going to talk about the relation between intercept theorem and midpoint theorem. And we will also apply intercept theorem to solve some unknowns. So boys and girls, let's have some review. Now in the last two lessons, we talked about midpoint theorem. And it means if you have AM and B equal, AN and C equal, they must be parallel. And of course, MN, which is just half of BC. And then we talk about intercept theorem. It means if you have three parallel straight lines, cutting AM and MB to be two equal intercepts, and in this case, the intercept on another side must be equal as well. So boys and girls, now I would like to change the intercept theorem a bit. I want to apply it in a triangle. So what do I mean? Now imagine. Now I'm going to shift this straight line to the left hand side. So imagine now we are going to push it and until the straight line intercept another at point A, and then I stop. So in this case, you will have another figure like this. Okay? After you shift it to the left, it becomes another figure. Boys and girls, in this case, can you see a triangle? Do you think it looks very similar to the one on the top left hand corner? So what I'm going to tell you, boys and girls, for midpoint theorem, it means if you have a triangle and then you find out the intercepts on the left, the intercepts on the right, if they are all equal, MN parallel to BC. And now, in intercept theorem, if you apply it in a triangle, it's the opposite of midpoint theorem. If you have AM equal to MB, the first pair of intercepts, they are equal, and you find out MN and BC, they are parallel. In this case, I know another pair of intercepts, AN and NC, they must be equal as well. So what I want to tell you, boys and girls, they are just the opposite of each other. For midpoint theorem, you are given two pairs of equal intercepts in order to prove they are parallel. For intercept theorem, it's the opposite. You are given one pair of equal intercepts and parallel MN and BC, and so you can conclude another pair of intercepts, they are equal. So I remember it this way. For intercept theorem, if you look at the name, it's about intercept. That means you can use it to find intercept. So that means finding AN and NC. Okay? For midpoint theorem, midpoint, that means you know the midpoint of AB and AC already. That means you are given equal intercepts already. So midpoint theorem is used for parallel straight lines. So boys and girls, now I would like to apply them in one of the examples. Can you turn to page 52 of your textbook, page 52, and look at example 4.23. Now in this example, you can see a figure and you're given lots of information. For example, parallel straight line, AE, EB, they are equal, okay? Boys and girls, you're asked to find out what is the value of X, Y, Z, okay? So first of all, boys and girls, I look at this triangle first, this triangle, okay? You are given AE equal to EB. You have one pair of intercept, equal intercept already. You have parallel straight line. So in this case, you can find out AG and GC. And because now we are finding intercept, that means you can use intercept theorem. According to intercept theorem, if AE equal to EB and they are parallel, 5 and X, they are the same. So X equal to 5. That is what about the first part in the solution. Okay? And what about next? If you have 5 cm and x, you know this is 5 as well. That means you are given they are equal already. And parallel straight line, again, using intercept theorem, you can find out y must be 3. Okay, so that is the second part. Okay, because they are equal, they are parallel, so y is 3. And lastly, how about finding z? Now, if you have AE equal to EB, and now you know x is 5 already, so x is 5, so they are equal. And that means you have 2 pairs of equal intercepts. So in this case, they are parallel, and more than that, you know, according to midpoint theorem, EG is half of the base, so Z will be 6. So what you need to write down, which is they are equal, okay, and they are equal as well. So according to midpoint theorem, EG is half of BC, so equal to 6. So boys and girls, to conclude, what I want to remind you, if you look at midpoint theorem and intercept theorem, actually you can say they are just the opposite of each other. For midpoint theorem, you can use it to find parallel straight lines. For intercept theorem, you just look at the name of it, you know it is for finding intercept. That means when you have one pair of equal intercept and parallel straight line, you can find out another pair of intercepts. So to conclude, intercept theorem to find intercepts, midpoint theorem to prove parallel straight lines. But of course, sometimes you will be asked to find out the length, okay, which is about MN and BC, okay, and MN is actually half of it. So that's all for the lesson today. Thank you for watching.